Hi everybody, this is Joe slash FoozleCC, and today I'm going to be showing how you can implement a third-person camera inside of your Construct 3 video game. There's been a lot of new fun, exciting features for 3D inside of Construct 3, and this just really complements it. So with that said, let's go ahead and jump on in. Okay, first and foremost, Construct.net, awesome new homepage. Go check it out if you have not yet. Super slick, very nicely done. Love the 3D cube. Good job. Anyways, so release 262 a couple weeks ago gave us the 3D camera, and since then, release 263 and 264 have added a couple of new things, including orthographic projection, as well as a mouse look. We're going to focus on a third-person camera implementation. Now, inside of the editor, we did have a nice project given to us, which is a first-person platformer example. Let's give this a play and see what we're talking about here. All right, first of all, this is the new mouse look, which is great. And, you know, this is pretty cool, right? That we can do, you know, look around and actually direct where we want our camera to look and move relative to where we're looking, so we can kind of strafe, right? And we can do all this, and that's fantastic. But what I'm going to do is I'm going to convert this into a third-person camera and introduce some controls for our player and some art to see what that might look like. Okay, so now we're inside of our third-person platformer. Let's give this a play before we dive in and talk about the event sheet and how this is working. So I've introduced a new set of artwork here that's moving around on a 3D shape with the faces, with one of the faces being set to an animated sprite, and I'm toggling between different four-directional sprite artwork to make it look, you know, kind of that 2.5D or that 2D moving around a 3D world look. I think it's kind of got a unique feel, and I thought it was kind of cool. So anyways, this is the, you know, the camera is automatically following the player. Now, the way that I've set this up is that it's an orbit camera, so that I am actually able to let's, you know, change the angle at which we're looking at the character. I can also zoom in, I can zoom out radially, right? And as far as the azimuthal angle, which is, you know, where the camera kind of turns to look at where you're going, that is kind of being handled automatically. So let's look at some math on Wikipedia real quick, and then we'll dive in after we've grounded ourselves. Okay, so Wikipedia does a great job of describing this. It's a quick read, but it does ground us. So let's just take a look at this. In order for this to work, we're actually going to use a spherical coordinate system. I could do something more simplistic and just maybe put it a certain distance behind the character and use even the built-in Construct 3 3D camera plugin to say, hey, keep it parallel at all times and just look at my player. And that'd be a really straightforward way of getting a third-person camera. But I want to make it a little bit more fancy and make it an orbital camera and use a spherical coordinate system. So that's what we're going to talk about today. In order to define our spherical coordinate system, the first thing we need is an origin. And think about this as like where our player is, and I'm going to define that as our look X, look Y, and look Z. And then in order to define where our camera is, we really can define in a spherical coordinate system the X, Y, and Z using what's called a azimuthal angle, which is this, which is like what plane or where's my camera kind of, you know, looking from an angle perspective. As I go to the left, I want it to kind of, you know, turn to the left so I can look that way. And then this is the polar angle, sometimes called inclination angle, but this is like, you know, what's my perspective in terms of how I'm looking down on the character. And then R is my radial distance away from the character, or my look position that my camera actually is. And then I have these three variables. I can actually translate them back and forth to X, Y, and Z as needed, so that I can make use of the 3D camera plugin to actually plug in my X, Y, and Z using my R, my azimuthal angle, and my polar angle. So now that I have that, let's jump into the event sheet and show how it's implemented. So in the event sheet, I do have some extra sections here that I'm not going to dive into today, including player controls and, you know, how I'm handling my artwork for it to show my four-directional, you know, sprite artwork inside of the game. Take a look at that at your own time. Link to the download in the description. Let's talk about the third-person camera. So we talked about how we need those three variables. Well, what we're actually going to do is we're kind of going to duplicate those. I'm going to set what my target azimuthal, radial distance, and my polar angle is, and then I'm going to be lerping to those positions for my actual camera value, and that'll make the camera a little bit more smoother rather than just hard coding it to always being exactly equal to the target positions. The other thing that we need to talk about is I'm going to make use of this camera bounds. Actually, let me go ahead and turn the visibility of this on, and let's talk about this for a second. So what I'm actually doing here is I'm making use of this red dot, and this red dot is actually making use of the layer to canvas, canvas to layer functionality, which can actually pass from the 3D layer up to this 2D layer, which I've called camera bounds, which has 0 parallax on it. I can pass the position from 3D space to 2D space on this layer. And this is really useful because what I can do is I can actually use this position relative to these camera bound boxes to create some useful variables that we can use in our controls. For instance, maybe you don't want the camera to move as long as that red dot is inside of this red square. And then with this green square, you might decide, which is what we're going to do here, is based off of how far away I'm getting from the red dot, from the red bounding box into the green bounding box. I want to more quickly correct my camera position so that I never really lose focus of my character. So let's go over to the right. You can see that the camera's azimuthal angle is actually changing so that I don't lose focus of it. Similarly, for the top and bottom, I can change where my my distance away from the camera is, as well as my polar angle isn't being controlled by this. I'm largely correcting and keeping my camera in view, my character in view, only using the azimuthal as well as the look X, Y, and Z position. So other than me manually changing the polar angle or the radial distance, this implementation only uses the azimuthal angle and then the XYZ look in order to keep my character always in view. And you can introduce some more complicated schemes, but that's how this one is implemented. Okay, let's go back. So now that we've seen that, let's talk about how the event sheet looks. So the very first thing that we need to do is we need to introduce some control ratios which are going to help our character stay inside of the viewport. And that's what we were just talking about with that red dot relative to the bounding box edges of the green and red boxes on that 2D layer. What I'm able to do with that is I can actually get a percent variable of how far to the left or how far out to the right or how far out to the top or how far out to the bottom that my characters are. Just looking at an example at the top, I'm just looking at, hey, that red dot's Y minus the bounding box top of my red box divided by the distance between the bounding box top of my green and the bounding box top of my red. So if you look at that inside of the layout, I'm finding what's the ratio of how far away I am from this edge between over this distance. And that gives me a useful variable to use in my controls. Okay, now that we have those controls, the next thing that we need to do is I also wanted to introduce some user input control for us to be able to change the radial distance and the polar angle. Now, I'm using a simple if this key is down command, change it, but you might want to introduce something more dynamic and automatic so that the player isn't responsible for doing that. For instance, maybe your speed will change the radial distance, or maybe for polar angle, which we're not going to cover today, you start to introduce some more complicated, hey, my camera's colliding with this other thing and I can't see my character anymore, so I need to respond to it. But hopefully this gives you the foundation for understanding how you might approach that problem and what controls you have to be able to fix it. So this is a Y down or H down or I, or M, and that's allowing me to change these values. And I set some bounds within I'm able to do it for both the radial distance and the polar angle. But ultimately, I'm just setting my target value distance offset, so that when I actually get to implementing my 3 different variables that we need, I'm able to use those offset values that I'm toggling as the user inside of that equation. Okay, so let's come in and look at now the next main section. Now that we've got some useful ratios and we have some inputs from the player, it's time to actually compute the different things that we need. the first thing that we need is the origin. So the look X, look Y, and look Z. And if you look here, the way that I have this set is largely I'm going to make use of those control ratios so that I'm able to update my X, Y, and Z. If I'm outside of that red box, I want to start updating it to be closer to where the player actually is. So before I do the X, Y, and Z, I do have one additional check here, and this is where, imagine if your character is falling or it's going down a certain trajectory where it stays in that red box, but it's getting further and further and further away. And I didn't really want it to be able to keep going away indefinitely. So I do have an additional check here where I compute the player distance away from the camera. And I can use this player distance to compare it against, how far I'm willing to get from what I initially set as my radial distance, so that if I start to get too far away, I can actually use hey, if I get really, really far away, I can use that percent of how far away I am to speed up getting closer back to the player, so that I have a nice ratio that I'm calling percent to camera player distance max radial offset. Holy crap, that's a big variable. But what this lets me do is I have a nice useful value that I can then use to help correct X, Y, and Z as I need. Like I said, link in the description down below. I'm not going to go into every nuanced detail here. You guys can open up the project and give it a look on your own. But this is a useful variable that lets me correct for when the player gets too far away, even though they manage to stay inside of that red box. I don't want them to keep getting smaller and smaller and smaller into the screen. Okay, so let's look at our look X equation. What I've done here is I'm lerping between my existing look X. And remember, we're defining our origin. So where's my camera looking? And I'm going to lerp to the player's position. Now, if I wanted to, I could kind of just blow all this away and just set like a value like 3 times DT. And I would just always follow my player, regardless of the whole camera bounds thing. And feel free to do that in your game. I wanted to introduce the concept of being able to move around a little bit without the camera moving until I get outside of a certain box on the viewport. So what I've done is, you can see I have the look XY lerp speed ref, which is just a, think of that as like 8 or whatever I set it to, is like 6 times DT, right? But I'm multiplying it by the percent to camera bounds max. And all that is it's just a max of all of these different ratios that we computed. So if any of the, ratios, for AKA if you're outside the box at all, I'm going to be able to correct my look X position because it's not going to be 0. If I'm inside of that red box, this goes to 0. So I'm multiplying it by 0 and it doesn't update the camera position's look. Similarly, this next one is a check of if my player is getting too far away, then also I want you to correct your position. So that's what we just talked about. So I have, hey, if I get outside the box, update, or hey, if I get too far away, update. And that's the exact same thing for the Y. So no change there. Okay, coming on down to the Z, you can see that it's very, very similar. The only thing that I do have is I have, instead of player.z elevation, I have look Z calc, which is just taking in my Z elevation plus how tall my character is, and then a little bit of an offset so I can dial in where I want that red dot to be. Do I want to be focusing on the head of my character, or maybe my body, or maybe my feet? So you can pick. So once you have that look Z calc, you lerp to it, and then you have a similar strategy where, hey, if it's the top or the bottom bounds is getting out of whack, you can update your look Z. Similarly, if the person's getting too far away, you can also update it. Okay, so that's look X, Y, and Z. We have an origin. All right, that's one of the hardest parts. The next thing I'm going to do is the azimuthal angle, and this is important. Now, what I'm going to be doing is I'm going to be setting my target to effectively what my player.angle is, minus 180. That's just how it kind of worked out. But think about, as your player is moving, I kind of want to be looking where my player is moving, right? And so as my player moves, if I need to be updating my azimuthal angle because I'm outside of the box, right? I want to be updating it towards wherever my player is looking, or wherever my player's angle is set. So what I do here is I basically say, hey, look, what's my difference between my target and my camera? And if it's greater than 1, then let's do an angle lerp between my camera's azimuthal angle and the target, and I'm going to set it as a percentage, using that percent of if I'm left or right. So as I go right out of the box or as I go left out of the box, I want to change my angle. Rather than top or bottom, that doesn't really matter. It's just left or right. So I'm finding what's my max between these two, which will effectively make it doesn't care if it's left or right for this equation. And then let's update my azimuthal angle accordingly. If I get close, just so I'm not continuously lerping, just go ahead and set it equal to the target. All right, so now that we have the azimuthal angle, we can go ahead and we can actually do the next calculation, which is the radial distance and polar z. And think of the azimuthal angle as giving you like your XY position in the game, whereas radial distance combined with polar angle gives you your z, and that's going to define where your z position will ultimately be. So what you can do is radial and polar do a similar thing where you set your target radial distance to a variable that I'm saying, what my min is. Let's just say it's 10. I don't want to be able to get closer than 10 pixels away or whatever from my character, plus this offset. And remember, this offset was being computed inside of these user input controls. So I can zoom in and I can zoom out. And then all I'm doing is I'm doing a lerp between my current camera distance and my target distance, so it's nice and smooth. When I get close, I just set it equal to the target. Polar angle, I'm doing the exact same thing. I allow the user to put their input in for the offset. I define a minimum, and I say, okay, what are my polar angle that I'm okay with? And I believe I have my minimum at like 80, and my minimum at like 5 or something like that. And you can go ahead and set whatever you want inside of your own game. Okay, so now we have our azimuthal angle and our radial distance and polar angle. So what we can do is now compute our XYZ using those values and the equations from Wikipedia. So if you come in here, you've got your XYZ, and you can define what those are based off of those 3 variables. So coming on back, that's exactly what we do. And what we can do is then set our player camera object equal to our X and our Y and our Z elevation equal to the Z. And we're pretty much there. Now we know where our look position is, and we know where our camera position is. So all we have to do is update the 3D camera using the look at position, which asks for your camera X, Y, and Z, your look X, look Y, and look Z, and then your up vector X, Y, and Z. And you just have to set this to 1, and you're good to go. So the rest is just some debug stuff so that we can put some text on the screen. Let's give it a play and talk about how ultimately this works out inside of your game. So we talked about how it updates when you go outside of the box. You can even change this box to make it, maybe have some more unique feel. So maybe you really want to be able to move around quite a bit without it updating the camera. So let's increase this to like that. And now, you've got a much bigger box that you can jump around in before it will update the camera. Let's just say I wanted to zoom out here and do something like this. Well, now you've got a nice big box that you can run around in, and it doesn't update your camera at all. So you could set this, and it's a nice flexible system for you to use inside of your games. And I was really pumped when I got this working. The next thing I really want to work on is how to actually set up some combat in here and have some interactions with some enemies, and how I'll handle the collision detection and all sorts of other things, how I handle the effects and the graphics. I want to keep playing with this demo a little bit longer, and we'll probably do a tutorial in the future on some of those items, including how do you handle when a camera is going inside of one of these boxes and you have a collision. I want to be able to come up with some algorithms to either move it closer to the character to get it out of the box, or some other scheme so that it minimizes how often your camera gets lost and you lose sight of your character. Okay, everybody, well, that's my tutorial for today. If you enjoyed that, please consider subscribing, giving it a thumbs up. It's free for you to do. It makes a big difference for me. Super appreciate you guys checking out this video. And as always, thank you to my Patreon supporters, James Welch, Clone13, McCall, Stevie Conlon, Lee Ching Ming. You guys are amazing. Really appreciate your support. Also, if you are interested in becoming a Patreon supporter, you do get access to all of my itch assets that I post up online for free. I love working with various artists and commissioning different work, and your Patreon support just allows me to do more of that. So thank you, everybody, and have a nice day.